Welcome back, pre-calc students, for day 4 notes, part 2, inequalities. First part was focusing on quadratics. This part is focusing on absolute value inequalities. A lot of similarities. The plus minus line, the strategies, a lot of things at the end are the exact same. We like those consistencies. Matter of fact, our third type, rational inequalities, which we'll do in day 5, use the same plus minus. The difference is, how do you obtain the numbers to partition the number line? So with the quadratic, we factor. With absolute values, we're going to do step 1. I'm going to do that in blue. Make it an equation with a positive and negative right side. No absolute value. Equation, -4 and 4. It says to solve, but I made a first example be nice and easy. There is no solve. Next, I'm going to create a plus minus line with those partitions. What does that mean? I'm left of -4. I'm between -4 and 4, and I'm right of 4. Third, I'm going to solve the inequality to 0. We're going to do this, and then we're going to just let it set for a second. Absolute value of x. Move the -4 over, is greater than or equal to 0. I always do that. Why? Because that's what we're going to plug into. Now I'm going to pick a number in each region. How about -6, 0, and 6? And I'm going to plug into that green inequality. -6, absolute value. 6. 6 minus 4, positive. Every region in that every number in that region is positive. 0, absolute value 0, minus 4, negative. Every number in that region is negative. 6, absolute value 6, minus 4 is positive. Everyone's positive. And now, based on the inequality, I'm going to go back to blue. I want positives. So that means the first region's a winner. X is less than or equal to -4, or x is greater than or equal to 4. Very similar strategies to the quadratic. Again, just the idea of getting the partition numbers. So let's take another example. Blue, make 2 equations. We're going to drop that inequality. Absolute value of x minus 2 equals -2. Absolute value of x minus 2 equals positive 2. Okay? If we solve those, get rid of the absolute values. X minus 2 equals -2. Add the 2 over, x equals 0. X minus 2 equals 2. Add the 2 over, x equals 4. I just obtained my 2 plus minus line partition numbers. Left of 0 is one region, between 0 and 4 is another region, and to the right of 4 is the third region. I'm now going to go back and move that 2 over temporarily so I can use it later. Give me a number to the left of 0. How does -2 sound? Number between 0 and 4, 2. The number right of 4, 6. Plug into green. -2 minus 2 is -4. Absolute value of -4 is 4. Minus 2 is a positive. Plug into green. 2 minus 2 is 0. 0 minus 2 is negative. Plug into green. 6 minus 2 is 4. Absolute value of 4 is 4. Minus 2 is positive. Sorry, I didn't put a black dot up here for step 4. And the last step, choose the intervals that match the inequality. Less than 0, negative. I want that region in the middle, x. Any number bigger than 0, but less than 4, it's not inclusive, so I am done. 2 would work in that original. 1 would work in that original. 7 would not work. -10 would not work. Let's keep moving. Another one, blue steps. 2x minus 6. Notice I just dropped the absolute values. Equals -8. 2x minus 6 equals 8. This is just to get the partitions. The absolute value doesn't really mean much right now. Add 6. 2x equals -2. X equals -1. Add 6. 2x equals 14. Divide by 2. X equals 7. I found my partitions. I'm going to red. -1 left, between -1 and 7, right of 7. I'm going to now move that 8 over. Kind of getting the mechanics here, greater than 0. Okay, I'm going to plug 3 black numbers, -2, 0, and 8, into green. -2 times 2 is -4. -4 minus 6 is -10. Absolute value of -10 is 10. 10 minus 8 is a positive number. 0 minus 6 is -6. Absolute value of -6 is 6. 6 minus 8 is a negative number. And 8 times 2 is 16. Minus 6 is 10. Absolute value of 10 is 10. Minus 8 is positive. And I know you're getting this pattern, this plus minus plus pattern. Good for you. It saves you some steps. That's awesome. Last part, what do I want? I want greater than 0. I want pluses. I want x less than -1 or x is greater than 7. I could try a number like 10 into my original. 2 times 10 is 20, minus 6 is 14. Absolute value of 14 is 14, greater than 8. It works. All right, example 4. Must be something to it. I put a star next to it. Let's follow our normal steps. Two equations, my bad, I almost misspoke, equal to the positive right side and the negative right side. I'm going to solve each one of them for x. Subtract an x over, 2x, 2 equals -4x, x equals -1/2. Subtract x, 2 equals 2x, divide by 2, x equals 1. I found my partitions. Blue to red. Again, that's what practice is for, folks. Get this down. Understand the concepts. Go back to green. I'm moving that 3x over. X plus 2, absolute value, minus 3x is less than or equal to 0. I know what you're thinking. Less than or equal to 0 means you're going to take the negatives at the end. Not yet. Give me a number. -2. I love 0. +2. I'm going to plug them into green, right? -2 minus 2 is 0. Absolute value of 0 is 0. -3 times -2 is +6. 0 plus 2 is 2. Absolute value of 2 is 2. 3 times 0 is 0. 2 minus 0 is positive. Whoa, must have made a mistake. Positive, positive. I thought the signs always changed. Answer, that's why I put the stars on. We'll talk about that in a minute. And the last one, 2 plus 2 is 4. Absolute value of 4 is 4. 2 times 3 is 6. 4 minus 6 is a negative number. What do we want? Go back to blue for my last step. We want the negatives. We only want this last region. X is greater than or equal to 1. This negative last region right there. So, mathematics is all about finding patterns, learning what's going on. Why did we have sign changes here? Plus, minus, plus. Sign changes there, plus, minus, plus. Sign changes there, plus, minus, plus. But example 4, what was different? And if you think about it, I'm sure you will probably notice there was an X on the right side. So we're going to say, with X values on the right side, there may be no sign change at a partition. In other words, example 3, 8 on the right side. Had to be plus, minus, plus, or minus, plus, minus. Go back. 2 had to be plus, minus, plus, or minus, plus, minus. But this one could be sign change, maybe no sign change at one of the partitions. Sure enough, on each side of -1/2 is plus, plus. That's how we solve those.